What happens when we put something flammable into a humidifier? Well, that question all started with this. AliExpress likes to call it a 30 milliliter mini humidifier for car, home, office, portable, rechargeable, small wireless, personal face sprayer, cool mist maker, humidifier. Has a nice ring to it. Well, so why this? Well, literally on the second image of this listing, it gives you some ideas on how to use it. In case it wasn't apparent, it tells me I can use it for alcohol, disinfectant, and milk? I'm a sucker for good marketing. Plus, for a small upcharge, you can get the attachment that lets you spray it directly into your eyeball. But that's for another video. Today, I'm just wondering what happens when I put alcohol inside of this humidifier. So let's set up the test. I'm going to set up this test using isopropyl alcohol, which is commonly found in its diluted form in household products like rubbing alcohol, though rubbing alcohol can also be sold with ethanol. Actually, just stop. I cannot recommend that you do this at home. I have a technical background that prepares me for this kind of situation, and I also have the proper PPE, which is important if you plan on, say, living from the suspended weightless droplets of alcohol that will be floating in the air. Okay, proceed. Here we go. 3, 2, 1. You're not going to be able to sanitize your eyeballs with that. You know what I mean? Hi, it's me, Jackson, from the future. Now, this really bothered me. Why couldn't I get the alcohol to work in the humidifier? That is, after all, what they claimed. Basically, this sent me into a month-long research frenzy where I decided to learn everything that I could about atomization. By the way, that's the process where you go from this juicy liquid over to this very fine mist. This whole process works because of a little tiny metal disc that vibrates at a very high frequency. You can kind of think of it as a trampoline for water. You know when you were younger and you used to bounce on the trampoline back when your life was full of joy and you had friends bouncing there with you, and sometimes you would all bounce together and then one person would bounce super high into the air? Well, that's basically what's happening with this metal disc. The disc vibrates at a very specific frequency that launches very small water droplets into the air, creating a fine mist. By the way, I just have to mention that this whole process works because of crystals. Yes, crystals. Crystals are magic. Don't say that they aren't. The crystal girls were right all along. Now getting back to the problem at hand. These humidifiers are meant to work with water, despite the claim. They won't just work with anything. The tiny little metal disc that vibrates at an ultrasonic frequency is tuned for the properties of water. Properties like surface tension and viscosity, which water and alcohol do not share. Oh, oh, it's working. Whoa, 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 whoa. Okay. Oh, wait. Oh, there we go. 3, 2, 1. No, it stopped. Dang it. Oh, it's going again. Whoa, 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 whoa. Hold up. Pause. Did you see that? Let me go back. Right there. No flame gets produced when I'm out here, but it does work when I'm over here. And like, maybe that's intuitive to you. Yeah, obviously it's not going to work out here, but have you ever wondered why? This was supposed to be a short video, a dumb video even, one where I put something flammable into a humidifier, I light it on fire, and I call it a day. But that didn't work, so instead I have been reading research papers and textbooks, and I think I finally understand fire now. What I've learned from this is that oftentimes the interesting questions don't appear the first time you ask yourself, why? The interesting questions only appear when, like an overzealous child, you have asked yourself why enough times that you finally arrive at the root of it all. Why did the alcohol not light on fire? Because the mixture was too lean. Why was the mixture too lean? Because there weren't enough particles in the air to sustain a reaction. Well, why can't I just have a small flame for a small number of particles? Or even, why can't I take a single particle of fuel, add some heat to it, and light it on fire? And to understand that, we have to understand what fire actually is. In grade school, we were introduced to the idea that fire needs three things: fuel, oxygen, and heat. For example, you may have seen a chemical reaction that looks like this, where hydrogen fuel reacts with oxygen to form water. For the isopropyl alcohol in this humidifier, that reaction turns to this slightly more complicated formula. But in both of these cases, we don't go from just having fuel, adding oxygen, and then ending up with the final products. All of the spicy stuff happens in this arrow. Let's use this example of isopropyl alcohol. When we first apply heat to liquid isopropyl alcohol, we get a flammable vapor. As more heat is applied to the vapor, the bonds in the molecule begin to break. And this forms two reactive fragments called free radicals. Specifically, we get a fuel radical and a hydrogen radical. These two free radicals are in for a wild ride because in the next matter of nanoseconds, they are going to undergo dozens of chemical reactions, and there are many different scenarios that could play out, including this one, where a hydrogen radical goes on to collide with an oxygen molecule. If it does, it will increase the pool of free radicals. All of these free radicals have the potential to react with more alcohol in their own way, but in the end, they will produce more fuel radicals. What happens to the fuel radical is largely outside of the attention span for this video, but it too will undergo many different reactions as each reaction breaks it down from a larger molecule to something smaller and smaller and smaller until it has finally arrived at its destination as water and carbon dioxide. But fire also produces heat and light, so what about that? Well, the heat we feel from fire is produced from each of the reactions taking place during the chaos of free radicals reacting with fuel and with each other, while the light that fire produces comes from two sources: either a free radical that has so much energy that it produces a blue light as it loses some of that energy, or a yellow light as some of the carbon in the reaction becomes so hot that it begins to glow. All right, well, we did it. We unlocked the forbidden fire knowledge that Big Fire didn't want you to know. And with that, we can finally answer our original questions. Why flame here? Why no flame there? When you burn a tiny bit of alcohol, like the mist coming out of this humidifier, you only create a few free radicals. Those radicals want to react with more fuel to keep the chain reaction going, but the problem is, by the time they form, the mixture is so dispersed that instead of colliding with more fuel, they just bump into air, or just nothing useful. And this really is a small amount of fuel, like way smaller than what you would find even in the single pump from this spray bottle. So yeah, even though the chemistry works for a small amount of fuel or even a single particle, we don't get any flame because the flame we see is a macroscopic phenomenon from the millions upon millions of reactions that are all happening simultaneously. I've learned a lot in this process of having something not turn out the way that I thought it would. And if you've managed to stay this long in the video, then I hope you have learned something too. Thank you for watching. That ain't water, you know what I'm saying? It is. It's just water.